Welcome to today's lecture of Mechanics of Solids. We had solved the examples related to coplanar non-concurrent forces in the previous lecture. Let us go for another example with different pattern and different angle variations related to the same. So, in the first example, a force system as shown in figure, we have to find the magnitude, direction, and the perpendicular distance of the resultant force with respect to point O, means over here. So, for the given system, let us understand the value of 2, 2, 1, minus 2, and minus 2, minus 1. This 2 is for horizontal distance and this 2 is for vertical distance. And this 20 kilonewton force makes an angle of 45 degree with the horizontal x-axis. So it will have two components. First is your 20 cos 45 degree and your second will be 20 sine 45 degree. This 30 Newton force is horizontal, this 10 kilonewton is vertical, and it has a moment of minus 40 kilonewton into meter. So let us go for the first step, that is sigma h summation of all the horizontal forces equals to 0. So our first horizontal force is 30 kilonewton. So 30, and this 30 is going towards positive x-axis, hence it will be positive. Our second horizontal force is 20 cos 45 and it is also going towards positive x-axis, hence this will be positive. So plus 20 cos 45 degree. So sigma h will be 44.14 kilonewton, positive, so denoted by this sign. Now go for sigma v, summation of all the vertical forces. So first vertical force is 10 kilonewton and it is going towards minus y-axis, so minus 10, and second vertical force is 20 sine 45 and it is also going downwards, hence minus 20 sine 45 degree, which will be equals to minus 24.14 kilonewton. It is going towards negative y axis. Now we know that capital R resultant equals to under root of sigma square plus sigma v square. So the value of sigma h is 44.14 and value of sigma v is 24.14 with minus sign. So here we will get the value of resultant as 50.31 kilonewton. Since we know that tan theta equals to sigma v by sigma h. So value of sigma v as minus 24.14 and value of sigma h as 44.14. You will get the value of tan theta as minus 0.546. Therefore, theta will be equals to 28.67 degree. Here, in this example, value of sigma h is positive and value of sigma v is negative. Hence, our resultant will lie in fourth quadrant. So, now we will go for finding the perpendicular distance of resultant force with respect to point O. So, let R be at a perpendicular distance x from point O. So for that, considering the moment about point O, So let us show in this figure. Your first force is horizontal force, that is 30, and this 30 has -2 in x direction and -1 in y direction, and this force is in horizontal direction, and hence it will makes perpendicular direction with respect to y-axis. So this 30 kilonewton force will move towards point A in anti-clockwise direction, hence it will be negative. So our first component will be -30 into 1. And remember one thing, this distance can't be considered as -1. Here -1 is indicating that your vertical distance is in downward direction. So not consider minus sign while calculating the example. So first is your -30 into 1. Now your second case is 20 cos 45, and this is again horizontal, so it will make the perpendicular distance with respect to vertical axis. So 20 cos 45 into 2, and this will also move towards point O in anti-clockwise direction, so it will be negative. Then we will go for 20 sine 45. This is your vertical force, and hence this vertical force will make perpendicular distance with respect to horizontal axis. So plus 20 sine 45 into 1, and it is going in clockwise direction. Then 10 into, this is your again vertical force, and it will move towards point A in clockwise direction. So plus 10 into, it will mix with horizontal axis, that is 2. Then 40 kilonewton into meter, it is in clockwise direction and it will move towards point A in clockwise, hence it will be considered as plus. So I will write over all these figure. So our first is -30 into 1, then -20 cos 45 degree into 2, then plus 20 sin 45 degree into 1, plus 10 into 2, plus the moment is 40. So after solving, you will get the moment as minus 15.86 kilonewton into meter. And as we know that R into X equals to minus 15.86. So considering the value of R as 50.31, we will easily get the value of X as minus 15.86 upon 50.31. You will get the value of X in meter. So by this way, you have to find the value of resultant force having the magnitude, direction and the perpendicular distance. Now we will go for the another example. Find the equilibrium of the force system shown in figure. So here 20 kilonewton into meter is moment. Here 5 kilonewton makes an angle 75 degree with the horizontal x-axis, hence it will have two components. First will be 5 cos 75 degree and the second will be 5 sine 75 degree. Here also it makes an angle 60 degree. So first component will be 5 cos 60 degree and your second component will be 5 sine 60 degree. We had just resolved the figure, so it will be beneficial for us while calculating the value of sigma h and sigma v. Now we will go for sigma h. So sigma h equals to your first horizontal force, that is 5 cos 75 degree, and it is going towards negative x-axis, hence it will be minus 5 cos 75 degree, and this 5 cos 60 degree is also going towards negative x-axis, so minus 5 cos 60 degree, which will be equals to minus 6.29 kilonewton, or equals to 6.29 kilonewton in this direction. Now we will go for value of sigma v. So sigma v equals to this, my 575 is going in downward direction, so minus 5 sine 75 degree, and this 5 sine 60 is going in upward direction, so plus 5 sine 60 degree, and one additional force 6 kilonewton is going downward, so minus 6. So you will get the value of sigma v as minus 6.41 kilonewton, equals to 6.41 kilonewton in downward direction. Now we will use the equation capital R equals to under root of sigma h square plus sigma v square. So after putting the values of sigma h as 6.29 and sigma v as 6.41, we will get the value of resultant as 8.98 kilonewton. And we know that tan theta equals to sigma v by sigma h. Therefore, we will get the value of theta as 45.54 degree after inputting the values of sigma v and sigma h that we had obtained in the previous step. Since sigma h is negative and sigma v is negative, our resultant will lies in third quadrant. So now let us find the perpendicular distance. As our resultant lies in the third quadrant, so let us consider that R be at a perpendicular distance x from O. So for that, R into X, that is this force, and this R will move towards point O in clockwise direction, hence it will be positive, equals to 5 sine 75 degree, and this 575 degree will move towards point A in clockwise direction, and hence it will be positive, and this vertical force makes horizontal distance of 2 meter with respect to point O. So 57 sine 75 into 2. Now next will be 5 cos 75. This will move towards point O in anti-clockwise direction. So here minus 5 cos 75 degree into, this is your horizontal force, and hence this horizontal force makes the perpendicular distance with respect to vertical axis. So 5 cos 75 into 3. Next, 20 kilonewton into meter. It is moving towards point O in clockwise direction. So here plus 20. Then 5 sine 60 will be here, so it will having the same line of action, hence this will be eliminate. Now we will go for 5 cos 60, and 5 cos 60 move towards point A in clockwise direction, hence it will be plus, so plus 5 cos 60 degree into this horizontal force will makes the perpendicular distance with respect to y-axis, that is 3. So 5 cos 60 into 3. And lastly, this 6 kilonewton force will move towards point O over here. So plus 6 into this vertical force will makes the perpendicular distance with horizontal axis, so plus 6 into 4. And after putting the value of capital R as 8.98 we had obtained in the previous slide, so we will get the value of X as 6.37 meter from point O. Now we will go for another example. We have to determine the magnitude, direction, and the distance of resultant force with respect to point A. So first of all, let us go for value of sigma h. So the horizontal force, first horizontal force is your 25 kilonewton and it is going towards positive x-axis. So plus 25. Then 45 kilonewton. So here 45 kilonewton, total is your 90 degree, hence this angle will be 45 degree. So 45 cos 45 and the another force will be 45 sin 45. So this 45 cos 45 is going towards positive x-axis, hence I will write over here positive 45 cos 45 degree. Then 20 kilonewton over here. So 20 kilonewton, total is your 90 degree, hence half portion will be 45 degree. So 20 cos 45 and this will be your 20 sin 45 degree and it is going towards negative x-axis, hence it will be minus 20 cos 45 degree. So after solving this you will get sigma h as 42.68 kilo Newton. Now we will go for summation of all the vertical forces. So here the vertical force 20 is going upward, so plus 20. Then the vertical force 20 sine 45 is going upward, so plus 20 sine 45 degree. Here 45 sine 45 is going upward, so it will be plus 45 sine 45 degree, which will be equals to 65.96 kilo Newton. Therefore, R equals to under root of sigma square plus sigma v square. So we will get the value of R as 78.56 kilo Newton. And as we know that tan theta equals to summation of V upon summation of H. So we will get the value of tan theta as 1.545 and the value of theta as 57.08 degree. Since here in our example value of sigma h is positive and value of sigma v is positive, therefore our resultant will lies in first quadrant. So I will denote resultant over here in first quadrant. So let us assume that R be at a perpendicular distance x from point A. So for that we have to check the resultant. So therefore R into x, this resultant will move towards point A in anticlockwise direction, hence it will be negative. So minus Rx equals to your first force, that is 20. This 20 will move towards point A in anticlockwise direction, hence minus 20 into this force makes perpendicular distance with respect to point A over here. So 2 plus 2 plus 2, that is 6. So minus 20 into 6. Then next, Let us take this force 20 sine 45. So 20 sine 45 degree. This 20 sine 45 will move towards point A in anticlockwise direction. Hence, this will be negative into perpendicular distance. This makes a perpendicular distance of 2 meter over here from point A. Hence, 2. Then 20 cos 45, it is this force, 20 cos 45 into, this makes the perpendicular distance over here, that is 4. So 20 cos 45 into 4, and it will move towards point A in anticlockwise direction, hence it will be negative. Then 25 kilonewton. This will move towards point A in clockwise direction, and it makes perpendicular distance of 2, 2, 2, 2, that is 8. So plus 25 into 8. Now this 45 kilonewton force produce the zero moment, as this is your 45 cos 45, and this will be your 45 sin 45. So 45 cos 45 makes perpendicular distance 2 from this point, and it will move in clockwise direction, and 45 sin 45 will move in anti-clockwise direction, hence negative, and it makes the perpendicular distance of 2 meter only. So this both will be exactly equals to each other, hence it will produce zero moment. So after putting the value of R that we had calculated in the previous step as 78.56 Newton, we will get the value of X as 0.062 meter from point A. So these are the different types of examples related to the coplanar non-concurrent forces. In the next lecture, we will see some more example related to the same. Thank you.